Hello and welcome to my channel. Today we will discuss data mesh and how does it fit in the bigger data landscape of any enterprise. I will go through one of the projects I did implementing data mesh and data lakehouse to give you an understanding of what exactly I did and what technologies and what principles were followed. Anyway, let's start with the characteristics of what exactly is data mesh. Generally speaking, when we think data mesh, so many characteristics like these four over here, we think these are not possible on-prem. It's only possible in cloud. But it really is very easy and very straightforward once you look into it and look into the possibilities. I have implemented it and it works like a charm. So let's look at the characteristics. First is data ownership. One thing we change, and that's one of the basic principles, is data is not owned by IT. Data is owned by whoever is producing that data, sales, marketing, finance, or logistics. Data stays with them and they keep the ownership of that data. Second, data as a product. As you can see, that data has owners, SLAs, consumers. The rest is pretty much the same. I mean, it's not a new concept as a product, but it has to be there. Third one, again, is a very, very important one, and that actually is one of the major points, is the self-service. How can you have a data platform where you can be a user or being a department that has some data? How can we run reports, analytics on that data without having to request IT department for creating some sort of pipeline or granting some sort of access and waiting for something and then something not working or the resources are not available, all that kind of problems which we face pretty much every day. So, and the federated computational governance, and we'll look into that, how everything fits in. So this, as I said, is one of the projects that I have done previously, so I've taken some diagrams out of it, tried to get rid of all the company names and stuff like that. But this basically generally is a lake house, how the lake house itself is working. The data is coming from different sources, Airflow and Kafka, then Spark streaming and Apache Spark. ETL happens, data is stored in Iceberg table format, Parquet files, on MinIO S3 compatible buckets. From there, data is being, OLAP cubes are created and data is pulled into ClickHouse, which is then served from there. Followed the Delta Lake basically architecture when it comes to ETL or when it comes to the states of data while it's in while ETL is happening. Obviously, you've got gold and business level aggregates, but again, it's just one way of doing it, and obviously this is not exactly what I did, because this diagram is taken from a presentation for a enterprise's CTO, and so I had to do it some sort of explanation over there, going not too deep into it. But that, generally speaking, that's how it looks like. Our stack is Apache, ClickHouse, Trino. Let's just move on and we'll have quick. I mean, I would assume that if you are watching this video, you do understand the basic data landscape today, and you understand what data products are in use, especially on premises. But just to clarify, maybe you don't know one thing and you know other. Apache Spark, I think that everyone knows, that was serving the ETL and data transformations. Airflow, again, orchestration, DAGs, scheduling, logging. Iceberg is a table format that we use as a lake house, and ClickHouse as an OLAP engine that was for serving the reports. Trino is a query engine, a distributed query engine, a very fast, very I think one of the best out there, and I will explain where Trino fits in. Next, we have the storage layer where we've got MinIO S3, which is AWS S3 API compatible with pretty much all features of S3 block storage. With erasure coding, you've got striping, you've got predicate pushdown. Anyway, we'll look into that afterwards and how that speeds up our system. But again, performance is not the key point in this presentation, but I would just touch upon that. Kubernetes, again, that's a must for every enterprise in today. So Kubernetes, and the best thing about Kubernetes is that we can just spin up whatever we like, whenever we like, and bring it down, scale it, so how we like it. GitLab, a brilliant tool here for DevOps, the CI/CD pipelines to automate everything. As I said previously, self-service is one of the core components of data mesh, and that's where GitLab fits in, and it does wonders, really. Okay, from raw data to AI, let's say, I call this one, what exactly is happening? So what really is happening over here, as you can see, with Airflow, with Spark transformations, Parquet, changing into Iceberg table format, storing on MinIO S3, and then ClickHouse is picking up for whatever needs to be done with that, or directly your AI, ML, data science workload is taking Parquet files and reading them. Well, that point is pretty straightforward, nothing new over here, and it's just a normal ETL. And Lakehouse or even Data Warehouse would do something like that as well. I mean, not the Parquet and S3 part, even though, I mean, Teradata is going is pushing for MinIO now with S3 block storage. Anyway, taking a step back, but again, what's happening on top with GitLab is the self-service analytics. What we are doing is we are calling GitLab, and GitLab is spinning up Kubernetes pods and giving us some data on or to process. Well, that does explain some part of it, but let's look deeper into it, that what exactly happens when GitLab is called. As you can see, I mean, we said that self-service, decentralized data as a product, federated data, all these concepts or characteristics that we were speaking about. How am I, or how did I, as a solution architect and the team in general, we pulled it off, let's say, or we designed it. User requests basically some data on a portal. Now, data is owned on S3 buckets, is sitting on S3 buckets. Dimensional data is read-only available to anyone who has access to data. But fact data stays, again, read-only, but stays within buckets that belong to certain departments. So when data is needed, a user would request data from data management portal to, let's say, department 2. A user from department 2 requests data from fact tables from department 2 and department 1. Now, department 2, we assume that the user's own department, so they can approve themselves. Department 1, on the other hand, can be, let's say, marketing department, for our example. What this management portal would do, data management portal would do, it would send a request to the owner of the data, whoever approves or disapproves that request, and basically it would just send the request to that department. It has an expiry and it waits for an answer. If that request is approved, that bucket and that data where that fact table is stored, because it belongs to sales department within Iceberg, data access is granted. Now, again, everything is read-only here. You can, because ETL is already set up on Lakehouse level and OLAP level, and nothing changes in that. But what we have here is already pre-computed Parquet files, which are sitting there and can be accessed. Now, once we got approval from department 1, department 2 is already approved as well. All dimension tables are in a bucket that is available read-only to everyone. then that management portal kicks a GitLab CI/CD pipeline. And what basically that does is it creates, it sends, basically it has executors for Kubernetes. It creates pods, a Trino cluster. Why Trino? Why Trino was chosen for this step? Why not? Why didn't we stick with Spark, which was already there for ETL? Let's quickly look into that. First, Trino is SQL. Second, Trino has the benefit of using the S3 erasure coding, or let's say striping. So it can read data from multiple disks, and it can actually predicate push down where clauses. The filtering is actually pushed down right down to the Parquet file itself, where data is only the relevant data is pulled back and then computed. So all this with MinIO and Trino, with predicate pushdown and SQL, these two are the biggest reasons that Trino was chosen. So once Trino is created with all the access keys and secret keys with read-only access to data. Now, if you see these three buckets, one is the workspace bucket, which is the read-write. So what happened is that CI/CD pipeline created a branch within. Actually, how it works is creates a branch and that triggers this pipeline. So when a branch is created, a workspace is created on S3 in a bucket, which is read-write, while dimension and fact tables are made available as read-only. And Trino is the query engine sitting on that. Now you can perform all your tasks and you have access to your workspace. So you can store your results and use them later on, and whatever you want to do it with, or share or present or reporting. So whatever reason, that data can be stored inside your workspace. Your queries can be stored within your branch. And once the requirement is completed, branch can be deleted. Now, if the branch is deleted, everything, the accesses will be gone from there. The Trino cluster would be cleaned up and resources will be freed up. And at the same time, if the branch is not deleted, it has its expiry. And that is another feature that's coming from the data management portal. If the expiry is hit, then it would be cleaned up itself. So as you can see in this, if we quickly navigate back to the characteristics of the data mesh, decentralized data ownership, you saw that the fact tables are owned by the departments themselves. Data as a product that exactly is there. The security and the trustworthiness, again, the ETL pipelines are serving that data. The data is made available only read-only. So the trustworthiness is there. Self-service, everything is triggered via, almost everything is triggered via CI/CD pipeline. So no IT wouldn't even know that it happened. I think the only thing IT is concerned at that point in time, what resources are used by which department. So basically to build them. Apart from that, that's it. And federated computational governance, that again is coming via Kubernetes and GitLab. So that's how we implemented this data mesh project. It took from proof of concept to MVP 3 months. Obviously, at that time, ETL and all that processes were not built. It was just basically a test. And once MVP was achieved and then more resources were allocated, a working group of 30 people was created to reach MVP that had some developers, mainly data and DevOps guys, and MVP was achieved approximately, give or take a few weeks, 3 months. And after that, it stayed with us for approximately 1 year and then handed over to the customer, and it's working fine. So I guess that's it for today, and I hope to see you in the next video.